All right. All right, the recording started. So hi and welcome to the third data model workstream meeting, May 8th, 2019 edition. We have a light agenda. The purpose of this meeting is to mostly work on the data model proposal. There is a proposal link. Before we start going into the proposal, I had two main agenda topics. One is an introduction for new people, and we'll go on the status of the proposal and what could be done in the current state of the proposal, and how do we get to an actual PR, and kind of also setting a date to target for PR in the repo. And the other one is how the data model relates to webhooks. There have been some questions in yesterday's SIG cluster lifecycle meeting, and also maybe go into some light examples from how the webhook relates to the data model, but also what could be done and why we're proposing kind of having webhooks as an extension mechanism. For the status of the proposal, we have made some progress last week. So now we have a little bit more definition of what each types should do and shouldn't do. We also have some new tables that specify which metadata do we expect each type to have, if a type is namespace or it's not. We also added some fields to the spec and status. And there have been some comments on what's required, what's optional, and why required fields are required. If that's okay, I'm going to start sharing my screen so we can just go over some of the main points. One important thing that I think we have been struggling a little bit is the definition of provider. Today, provider is mostly what we call for V1 Alpha 2 an infrastructure provider. But in this new world, the definition kind of extends to more than just infrastructure. Given that we want to manage the lifecycle of a whole cluster, and one of the project goals is to and this proposal goal is to define what boundaries each types have and what functionality do we want to offer to users. The provider definition kind of extends now to multiple groups of actions. So I have been thinking more about what should be as a provider, and I think it's we can define it as just maybe a repository or something that provides code for cluster API to call out to and use to do some group of actions. And this group of actions, so far we have infrastructure related actions, for example, reconcile the network, and then in the AWS provider, the reconciliation of the network, which right now happens in the cluster actuator. We'll do its own thing, create a VPC, create subnets, and so on. Then we have the bootstrap piece. This was we kind of went back and forth on where should this leave, but in the end, we kind of saw the bootstrap as something that should be plugged in, given that different providers might want to have different use cases to bootstrap a control plane or bootstrap a machine. We've talked about offering a default provider in Cluster API for kubeadm, which doesn't have to live inside the Cluster API repo, but it could be made as part of this effort that we offer basic functionality, so that a new infrastructure provider can come in and say, I want to offer ways to bootstrap the infrastructure on a new cloud provider, for example, and mostly focusing maybe on machines, but at the same time we can use composable pieces that Cluster API can offer to bootstrap Kubernetes. And this is kind of powerful because we can reuse these pieces across multiple cloud providers. The other one is control plane, which could have like many variants. Even this one, we have talked about machine-baked control plane, which Cluster API can understand because machine is like a high-level object, or like a pod-based control plane, or a control plane that's like managed like outside for that's something that like could be brought in, like a control plane managed like completely outside of Cluster API, but Cluster API can be aware of that control plane. So this is how we expand the definition of provider. We're not talking about just like an infrastructure provider. We're talking about something that provides code, and this might live inside Cluster API and might live outside Cluster API. That's to be decided. Let's go into cluster now. So there have been some questions like why, like for example, we're talking about extension at this point in the data model. As a reminder, this is not like everything in this proposal, it's not set in stone. So we're trying to brainstorm and like realign with the extension mechanism proposal, which is probably going to be the first one to go into Cluster API when we have a decision on what to use. But to like kind of like move along and like understand like that we kind of like want to offer some extension points, but at the same time, we don't want to like close out like other mechanism to extend Cluster API. So using like webhooks or extension mechanisms, like it's mostly like it's a way to offer default functionality, but that won't close the door to, for example, like providers having their own controllers and their own reconciler. So I just wanted to make that clear that like this is like a work in progress and like a community effort. So we kind of like are pushing forward this example, given that it's like kind of like all interrelated, but we can always go back. And I would expect, like I have been saying, 1,000 iteration on this. Because we'll probably like iterate on it a lot, especially like with the control plane and node lifecycle making progress on their proposals. I would expect that we go back to these types and add more fields or remove some fields or change definition of others. Any questions so far?
May I add one thing?
Mm-hmm.
I just I want to add that, you know, what we're doing here, right, is we're reflecting on V1 Alpha 1, the initial design, the issues that we found, and sort of iterating, trying to improve on that. And I think, I mean, I hope that we all expect that we're going to make, you know, further mistakes, or, you know, introduce further shortcomings of V1 Alpha 2, and then, you know, in the next iteration, try to address those as well. That's all.
Yeah, that's a good point. Like, I would expect like there may be, so like we had like a lot of ideas before coming to these proposals, right? And then like we kind of like saw that like some pieces of it are kind of like far-fetched, and so like we try to like take a step back and kind of phrase it so it's like it doesn't take like 3 years to like do all the work, but we kind of cut down and make sure that like we can get to V1 Alpha 2 quicker, but also make like kind of like long-term plans and like make sure that the vision is still there.
Yeah, I mean, as a specific example, like we're introducing, you know, or we're splitting up the provider into, you know, infrastructure and bootstrap, and I think that's a direct response to what we saw in V1 Alpha 1, or what currently exists, where each provider ends up implementing bootstrap, but in fact, what has happened is all the providers have sort of copied, you know, the initial implementation, and it's all very similar. And we saw that, well, why can't we just have this common, and there are other benefits to that. But that's an example of why we're introducing extension points. It's not just because they're cool or modular or some other something else that might be trendy.
Yeah.
Yeah, to me, it seems like the bootstrap mechanism is not really directly mapped to creating a machine, and that possibly should just be another controller of some kind at a higher level. And it seems to me that particularly that kind of seems like it belongs at the machine set layer, not necessarily machine set per se, but it's seeming increasingly like the idea of a machine set doesn't make sense when your unit of work is a machine and you have to do specific things to specific machines to get them to join the cluster and manage their health and everything. And it just seems like machine sets no longer a fit for that kind of use case.
I'm not. I feel like we're talking about some very detailed things about machine set, which probably we could have a separate conversation about. Your comments about using a controller instead of a webhook, I think that's a completely legitimate point. And there are certain areas where we do have controllers. I'm not sure that webhooks are the ultimate way to break this down. It could be that in some areas we choose controllers, but I think we should have targeted discussions about those points.
Well, what I'm meaning to say is on the bootstrap effort, right? That doesn't seem like it's directly related to the atomic action of create a machine. But due to how we have the machine set to machine abstraction currently, there's not really a good place to do that effort other than in the machine itself. And that's what I was saying. From a higher level, machine set doesn't seem like it's really a good abstraction if this is the kind of work that you need to do to a machine.
So Michael, I understand exactly what you mean. I have a litany of comments about pro and con for various design points. What I'm suggesting is that there's some things that we would like to get out of this meeting in terms of dates, framework, and then we can start whittling away at these long lists of things. But I just don't know that we can just jump to one in the middle of this presentation, because there's a bunch of them, right? So I don't necessarily disagree with you. I think you make some good points. I just don't know that I'm prepared to talk about Bootstrap right now.
Well, I was just following on to whoever was commenting previously, just kind of staying on that topic. I'm not sure how we got all the way down there yet.
There's also the node group, node lifecycle work group, or what do you call it, work stream. So perhaps that sort of falls into those discussions more than the data model per se.
Yeah, so I think the goal for this work stream is like we want to have these high level kind of concepts, like we want to talk about those, and we want to make sure that like we understand like how they relate to each other, and like how we can like kind of have like responsibilities for each type or each provider. But at the same time, like I agree like with Daniel. It's like very early right now in the process that like to talk about like details on how like the bootstrap is going to happen. I do have like some sequence diagram that like I kind of built like to wrap my head around it, and I'll show that like soon. But I'd like to continue like on.
Well, I mean, in the context of this document and the data model is what I'm saying. If we're going to have bootstrap stuff, that belongs at the next higher level or some other component, and therefore it doesn't, in my opinion, belong on the machine type specifically.
But the thing is, if you consider the machine equating to a Kubernetes node, then separating the bootstrap basically removes that distinction.
I have a suggestion, and let me see what people think, which is, I think that there's generally agreement that like there's some definition of infrastructure maybe, and some definition of like somewhere there's a definition of how a machine comes up. And I think we're getting very hung up in many places about like the links between them. And so like, where does it belong in the machine? So does it belong in the machine? Like, is a cluster required? All these things. What if we didn't? What if we didn't? What if we didn't like have hard links? What if we sort of just had API types, and the discovery is sort of up to the implementation? And at least for V1 Alpha 2, we said, all right, so like we don't have an infrastructure ref, but a provider that is implementing infrastructure can go and discover in some way the infrastructure objects in some pattern that it expects. And then we can sort of develop those different things, the different infrastructure implementations, without really having to debate whether it's required, whether it's linked into the cluster or the machine or whatever it is.
Well, the point I was trying to make was we're trying to have, right, some shareable opt-in code for going from I have an instance to making it a node, right? And we could do that today if the machine controller's responsibility was to create an instance, give it some user data, and that's pretty much it. And then the machine set layer doesn't care what cloud that particular instance is living on, because it will just, use kubeadmin, SSH, or what have you over that instance, and do what it needs to do. So that's not really providers.
Let's hold on like into details. Like, we're not talking about SSH yet. We're not talking about like how do we get there. We're talking about.
I'm just saying, for example, whatever the mechanism is, right? I have an instance, right? It exists, right? That's the part that's unique between clouds. The part that's not really unique is turn instance from Ubuntu into Kubernetes node or whatever distribution you're using. And so I think if we focus the machine controller and the machine abstraction to just giving us an instance, that gives us some portability. We don't have to implement as many provider-specific things into the machine layer, and it alleviates the problem of having to write all these different kind of extension things in the machine layer.
So I think we're proposing the same things. We're just talking past each other at this point. We do want the extension point over the actual machine instantiation to be smaller and just related to the cloud provider specific bits. And we want the bootstrapping to work in either as a pre-boot step where it injects either like user data into the creation of the instance, or potentially a post-boot step where it SSHs into the machine, say, to perform those steps. I think the difference that we're talking is what do those abstractions specifically look like, and how are they implemented?
I agree. I mean, I don't think we're saying fundamentally different things. I want to ask about something Justin suggested, though. I think it might be a good idea to treat the types as perhaps being optional and different. I just want to point out a potential risk there. We did that last year with the cluster and machine objects and the debate about whether machines had to have clusters. That debate I saw a Slack message this morning about. So the debate is not over, and we should be scared of getting into that situation again.
Yeah, I'm against having a cluster reference. That's not really a good model for our use case. So to me, it doesn't make sense. When you provision an instance on AWS, it doesn't have a concept of cluster.
Well, so let me separate it there. Like, so the cluster API goal is to create Kubernetes clusters. I want to make that clear. Like, that's one of the project goals. It's written and was merged, and we kind of all agree on that. Machines, we don't want to get into create any machine. We want to create Kubernetes machines, Kubernetes nodes to be exact.
Yeah, that's what we're doing. It's but the difference is right now we want a clean separation of abstraction layers because there's not really anything consumable at the cluster layer. And so having a clean implementation of the machine layer will allow us to, adopt pieces in the future.
Yeah, so like
the goal is to have a staged adoption path, but that doesn't necessarily mean that that staged adoption path is the optimized use case. So you should definitely be able to consume a machine without consuming the rest of the things, but that doesn't mean that just consuming the machine individually should be the optimized use case.
Well, currently we have to patch the machine controller in order to do that because cluster is required.
Right. The other concern that I have is if we treat these as completely independent resources and don't allow for linking between them, then we end up in a situation where it's very easy to shoot ourselves in the foot with misconfiguration across the stack. So the CNI provider that you choose to deploy, you may not have the proper security groups configured, for example, for the node-to-node communication to happen properly. You may not be passing in the right API server arguments when you're bootstrapping the cluster. These are things that, for the more generalized people that are consuming all of cluster API, we should be able to provide kind of an easier path to, not ending up with a broken cluster due to misconfiguration of that type.
Yeah, I absolutely agree with Jason, you and David. You're like, it is not optimal, it is not ideal, but it may be a path forwards is all I was sort of suggesting. Like in the absence of consensus, can we do this to move forwards and build consensus, discover consensus, and then add the references where we have a.
I think you're right. As the default types as the intent of the types is better understood, it'll become less contentious. So, I don't want to argue about particular types, but I could right now. I think that once we understand it, we won't have to argue.
So Michael said that this model didn't really fit his use case, but I didn't hear him describe what his use case was, and I'm curious about that because it sounds like it might be a little bit similar to ours.
Sure. I work for Red Hat, and so our use
I do
case
too. Hi.
OpenShift, and so right now our abstraction is we consume the machine controller, and we have some providers that utilize a lot of bits from upstream, but a lot of it has been patched to suit our needs. And part of the thing here is we're using atomic host images that automatically bootstrap themselves into nodes. And so right now, the concept of a cluster is, completely not related to what we're doing with these pieces.
So with respect specifically to machine and bootstrapping, there is some type of user data or configuration that needs to be passed into that machine instance during creation, correct?
Yes, that's true. That's just regular cloud user data.
Right. So in that case, what I would see is there would be like a custom kind of OpenShift bootstrapping provider implementation that would gather the right information and feed that into the machine instantiation, and that's a way that at least the model as proposed would work for that use case.
Yeah, no, our provisioning of machines is an atomic operation. So there's no follow-on action that we have to coordinate on the machine itself. There's no other controller. The user data payload is sufficient to bootstrap the image into a Kubernetes node.
So that's the same thing we're doing with the AWS provider today. We inject user data into the machine on instantiation.
Yeah, may I comment something? Something I don't understand is that we are discussing this bootstrap specification in the machine, because if your case is that you create everything in an atomic action, then you don't have any action for bootstrapping. It's already done. It's still me action. The problem is that if you want to separate that, you can do it. I mean, Um, uh, I understand your point. I mean that in your case this is an atomic action. That's fine. Then your extension point or whatever, or your controller for bootstrapping is do nothing. But that is, I mean, but for those who want to actually just provide a physical machine, so to speak, and reuse some kind of genetic bootstrapping, they can do it. I mean, maybe I'm missing something in your point, but I don't believe this model prevents you to do nothing in bootstrapping because your machine is already bootstrapped.
Yeah, so just
to this point, I was just speaking about specifically the cluster field. That's the part that is currently required in the machine controller, and we had to patch the machine controller.
So
okay, that's another discussion, but we have been discussing a lot about the bootstrapping. I got your point on the cluster. I personally don't have a strong opinion. I understand your point. I understand it's an issue, but it's like we have been talking about the bootstrapping and the atomic action and all that. I understand is your use case, but I don't know how this relate to the cluster. I'm sorry, I was missing in the conversation.
Well, I
What
mean,
is
if you
the
think
expectation
long-term,
for what that
like,
cluster field would be used for?
So just to like go into a little bit of more details, like as Daniel mentioned before, a lot of these kind of like things that we're putting in this proposal came from what we saw in V1 Alpha 1. V1 Alpha 1 right now like makes the cluster completely optional, and that has like two repercussions on both the provider and the code that like support that we have in cluster API itself. So, for example, the provider, we have seen a lot of users being confused on why we specify the cluster link as a label. And in the very beginning, historically, we actually didn't have the ability to have multiple clusters in the same namespace, which was pretty big limitation at the time. And what we did instead was to add like a label field on each machine set, or machine deployments to link a machine to a cluster. So that when cluster API goes into the reconcile loop for machines, it can also get the cluster that's related to it. If there is no cluster or the user like doesn't specify the cluster label, which is pretty easy to miss, the user has to go in and like tail logs, and we'll have a nil pointer exception, so it will probably file an issue. And we've seen this coming up a lot. Another thing that I want to add is like when we do have the links between cluster, machines, machine deployment, machine set, and all the other related things, we can enable use cases which are much more powerful. For example, in the new world, we can bubble up health summary, so we know which types are related to the cluster, and the cluster API can do this for any provider, saying, I'm just going to do like a basic health check on the nodes that like are part of this cluster, and tell the user if there is an action to be taken. Right? This is just an idea. The other powerful thing is deletion. We have had a support in V1 Alpha 1 for cascade deletion. So when I delete a cluster in V1 Alpha 1, all the machine deployments, all machine sets and machines also get deleted. And we can always do that if the cluster is actually linked to machines, or like vice versa. We also have owner references. So the machine having this field enables those use cases, and also like reinforces the concept that cluster API is offering Kubernetes clusters. And in this form, the cluster, it's not what we have today. Like you don't have to like kind of create a new controller, create an actuator. You like from a provider perspective, the cluster is like kind of all optional at this point. Like there's nothing in here that function as like a super required object. The purpose of it is to be an umbrella type for all the other types. So in that namespace, and then the namespace and the name provide uniqueness of like for that cluster and those machines that are in that cluster.
Okay, I understand why we have a cluster. I'm looking at the machine and the machine set, and both of them refer to the cluster. Why do we need both references?
Because machines have different purposes, right? Creating a machine allows you to allocate a single Kubernetes node, and a machine set allows you to allocate groups of nodes. And both have use cases. So in the cloud, if I'm in AWS, I may want to use auto-scaling groups, in which case a machine set concept makes the most sense. There are other environments where it may not make sense to have groups of nodes. Maybe every node is an individual. And so you want to be able to allocate a single node at a time. And the reason that I want a cluster object to be required is that I want a central point of control for the user. There are many other reasons, but for me, if I'm a user, I want to be able to create and delete clusters with a single kube delete command, right, or kube whatever.
Yeah, that makes sense. I'm trying to understand the relationship between the objects. I hadn't really considered using machines outside of a machine set. I mean, even in the bare metal cases that I'm dealing with, we put everything in a machine set because that gives us all the instructions about how those machines should be provisioned. So
for example, today in V1 Alpha 1, we use bare machines in the AWS provider for standing up the control plane instances. Because you don't want a machine set, scaling up or scaling down the control plane without the additional logic required around keeping that control plane healthy.
That's a good point. Another reason I had is you could start out with a machine set, and you may want to isolate a node without deleting it, perhaps for problem determination purposes. So by allowing the machine to be like moved in and out of a machine set, you can have finer grained control.
Okay. Yeah, that's a case I hadn't really considered either. That's interesting. Thanks.
Of course. In case of the Bootstrap reference, I know we have gone back and forth on this a lot. The definition of Bootstrap, it is kind of meant to be atomic, but also cover the use cases where we can have like a Cloud Init like user data field. So we can inject like a startup script. So it should probably cover both use cases of like a pre-boot or post-boot configuration. So this kind of covers the bare metal use case as well, where you have to SSH into a machine, for example, and run a script instead. So the purpose of this being pluggable is to enable more than just like atomic use cases, because not all cloud providers can cover those use cases.
And I'll ask again why that's on the machine instead of, I guess, maybe the cluster or whatever the extension configuration, somewhere like that. Like you would expect to do different things for multiple machines within the same cluster?
So the answer is yes, because you could have, for example, like machines acting as a control plane, or machines like having later on different roles, which we're not going to yet for the purpose of this proposal. But like one example is like we have talked about bringing support for etcd ADM when it's ready. And like I would expect like this Bootstrap ref to give us like a powerful enough abstraction on a machine that can like enable like other use cases as well down the road. Always in like the context of like building a Kubernetes cluster.
It does seem like though that would be a better abstraction for the next layer up, because an individual master doesn't know that it's the first master or the third master, and if the higher level provider is saying, okay, I'm going to provision 3 machines with this image and with this user data, and then I'm going to go ahead and bootstrap those into masters. That's obviously a layer above provisioning a machine. And I think coordinating that those kind of complex actions from one host to another might prove to be difficult when it comes to further down the life cycle management of upgrades and things like that. You're going to be building all of that kind of upgrade logic into that next level controller anyway. So that next level controller is going to have to like call down into the machine and wait for the machine report, etc., and then call down into the next one, etc. And
So that's not necessarily true. As Jason mentioned, we're looking to bring control planes as machines, like individual machines and non-machine sets, to get so that like we have like management of those machines and not rely on the machine
who's
set.
managing those machines? The cluster API, the
A
cluster
control
layer?
plane provider. A control plane provider will manage those machines.
Okay, but you
So
can see how then that's kind of like the same concept of bootstrapping a regular node. Then if you're already creating a quote unquote control plane provider, it sounds like you need something more generic like a role provider or something like that.
Yeah, it feels a bit like we're avoiding declaring roles for machines when they would actually be helpful in a few of these cases.
I agree with that, and I think that like it's kind of outside of the scope of this PR because it's too early in the process to talk about roles. Like, and it kind of like a role like.
Can you justify that assertion? I don't know. I mean, we're talking about it, so.
Well,
yeah,
what rules do we define though? Do we define like does a machine only have a singular role? Can a machine have multiple roles? How do we compose those roles?
Well, let's take a step back and let's talk about what your idea was for what this control plane provider looks like, because this, it might be in the document, but this the first kind of awareness I've got about where that actually fits into this puzzle. And it's hard to have these conversations like when you've got an idea about this and I don't. And that's probably, on my part, I didn't read all the documentation, but
also consider the control plane that was coming that there are not necessarily be machines. For instance, for the Gardener project, that was one of the projects around this initiative also, they provide a control plane a spot. So there is no machine. The control plane provider basically what it does is that it deploys on top of an existing cluster, which is not managed necessarily by cluster API, something that is there, and its purpose is to support all the control plane for other clusters, and that's one example. So you don't really have machines there, and that's why the control plane as a different entity. Or also think that it also fit the case that we have a managed control plane that is provided by a cloud provider. But you don't really have machine or anything, just only ask someone, give me a control plane and give me the endpoint from that control plane, and that is.
One other thing I want to point out is that like this bootstrap is a reference, so it can be reused across multiple machines. So like if that's specified in the template of machine set, that will fulfill your use case of reusing that bootstrap reference across multiple machines. In the end, like we can always like bring this up in a future iteration, like up the stack. But it kind of like what we saw from like, especially for the AWS provider, is we do inject per machine and has been useful so far, like injecting per machine, especially to differentiate between control plane and workers. So.
Perhaps I missed this, but wasn't the control plane an actual object on its own in prior versions? And then something like a control plane provider creating machines or pods is a normal flow.
I don't think we ever supported that flow, unless I'm missing some history before I joined the project.
No, I'm saying in previous versions of the data model proposal, not in versions of the capital itself.
Yes. The control plane was at some point a different type. We had like kind of like this proposal and some example like reviewed from Kubernetes API reviewers, and they like kind of not push but suggested like to revisit like the types, because creating too many types like it's kind of taxing on the user at that point. And given the one-on-one relationship between cluster and control plane, In this case, we kind of prefer that to bring control plane in the cluster. But yes, in a future iteration could be moved outside if there's use cases or reasons to do so.
So if you have a control plane creating machines and machine sets creating machines, then wouldn't it make sense to have the control plane as an object on its own with the controller on it, or an optional controller on its own?
So the answer is, like, in this world, it would be optional. Like the control plane here, it's like all optional, but the difference is, like, we have a provider reference, which here it would kind of like point to, like, as the description says, like, to an object offered by a cloud provider. So what that means, like, let's say that we have a machine-based control plane. We would expect like a
machine control plane.
Yeah, like a control plane backed by machines. We would expect to have a type it's called something like that. And that would live outside of Cluster API.
Okay, that makes sense. Cool.
For the purpose of this proposal, we also have machine-set and machine deploying. So we don't expect many changes to these. That's why, like, we kind of haven't go into many details yet. One thing about the machine class. As of today, machine class is defined as like a templating mechanism for machines. In this new world, the machine class is actually a required field, which would dictate the size of the machine. So anything, Jason, you had a good definition of this. Like we said, anything related to kind of the size of Kubernetes node, like.
Yeah, it would be sizing related to scheduling concerns. So that way you're not tying all of the configuration that would be required for autoscaler operation into the machine class. You're limiting the machine class to specifically be around sizing.
Yes, and I think there was an open PR today in the machine class to add the two more fields for the autoscaler, which I think it's capacity and locatable. So that would kind of like dictate the machine class in the new V1 Alpha 2.
And is the intent here that the parameters would be something that the provider would be aware of and understand what those fields are, what the keys and the values mean?
Yeah, we kind of went back and forth on like saying, like, should this be like again, like on one type that like the provider offers, or kind of follow the storage class that like has parameters, and then it would just understand. At the end, like, we kind of went for parameters to kind of align, but also like simplify, because in one of the first iteration, as we were saying before, like, we had a lot of types, and it was getting taxing on the user, or like me as a user, to kind of like reason about all those types.
Okay, so how, as a provider author, how do I declare what those things are so that my users understand what they can fill in? Is there some automated way to do that, or is it just I have to write documentation and they have to go read it?
I would expect you can write documentation, or I mean, like, there's also you can have like admission controllers, validation. The trick there is that like we will need to kind of like test and fill this out.
Yeah, I mean, an admission controller can tell me if they're trying to submit bad data, and can tell them, but it's not going to tell them what the right names are, you know, if they use the wrong name for a field, right? So that's the thing I'm worried about, is the usability of the actual API. This seems like a really important piece of the interaction with the end user and the provider. So
yeah, agreed. And we can always come back to it and kind of like make it more typed. Again, this is nothing it's set in stone here. It's good for brainstorming.
And so one of the concerns I have with this type too, especially as we expose the autoscaler fields, is that if like with the proposal today to add the autoscaler fields, the user themselves would have to sync kind of the configuration in the machine class. So like the instance size for AWS, you know, how large they want their EBS volume to be, that sort of thing. And they would also have to make sure to sync that with the kind of scheduling types for the auto-scaling fields. I would foresee there to be some type of extension point here that the provider would have to implement so that the user would just provide the provider-specific data and the provider would then fill in the kind of scheduling data that the autoscaler would consume.
Since this is only referenced by name elsewhere, I would almost rather have the provider just define each of these class objects itself so that it can put in the spec what it expects to see and what it supports.
The problem then is, how do we expose the autoscaler fields correctly to an external autoscaler that
Jason, but you can mix. You can mix. I mean, you can have these autoscaler fields and the provider as a specific class, like a label, a name, and say, and this is the AWS, blah blah blah, and the provider knows what to do that.
Yeah,
I think that it's a compromise solution, because otherwise, I know having these fields there. I mean, it's like, I don't know. It's going to be tricky to handle these objects.
I figured like each provider could create like a reference implementation for a machine class. It probably should have 3 fields, right? The name, and that maps to whatever a particular provider calls a flavor or an instance type, right? And so every provider can just always read that field. And then the cluster autoscaler cares about CPU and RAM. So 3 fields, and that's really all the information I think you need in there. And then so who?
I think it's more than those fields. For the autoscaler, I think it's more than that. I think it also takes into account like GPUs and storage space as well.
I was going to say there are
the autoscaler fields is a struct type that gets incorporated into the spec of all of these things so that it can be clearly defined, but it doesn't.
Yeah, there are 2 sort of design patterns that I'm aware of here. So one of them is effectively duck typing, where you make sure that even if you have AWS machine class and GCP machine class, that they have the same fields in the same places, which, as you say, Doug, you can implement with a common struct. The other one is that GCE machine class and AWS machine class both reference a autoscaler information kind, like an external common object. And I think either one of those is reasonable.
Yeah, the autoscaler struct sounds reasonable. And I think the key takeaway is who's in charge of putting all these mappings from autoscaler stuff to the machine class. And I think what we should start is, have everybody, define one example implementation, and if they want to create some automated tooling to create more of these machine classes for them to consume, that's cool. But as a starting point, just create the one, because it's not really a blocker on having to do it automatically.
Yeah, sounds good. The last 2 types, and I'm kind of marked these 2 as TBD. Like we'll wait on the extension mechanism to kind of like define the requirements for what extension and how, like which tool we want to use as extension, and kind of fill in these fields. The main purpose of these 2 kinds, the extension configuration would be something like it is related to a cluster, so it's in here, but it could be reused also like across clusters. So this is to enable like kind of like more complex scenarios. Like providers might have like a reference implementation, but let's say like for example you want OpenShift running on AWS. The idea is that like you could mix like the API groups with different providers so that you can have more complex scenarios that will fit more use cases. That's for the extension configuration. Still TBD what's that kind of look like. There is like an example spec which could map like groups of actions, so like infrastructure bootstrap, etc., to the name of the register extension, which brings to the extension registration. which if we go for like a webhook approach, like will be something like, I want to register this, like for example, the AWS webhook provider, which kind of defines this field and it listens on this Kubernetes service and like, for example, maybe some authentication. And this kind of follows the Kubernetes admission controller webhooks in a generic idea, at least. Again, TBD what all of this is going to look like, and we'll just go back on it once we know more.
Yeah, well, if, I'm not in favor of the webhook model. I've used the validating webhooks before, and if you're trying to deploy a bunch of things in an automated fashion, start running into chicken and egg problems, especially around like CA certificates and that kind of thing. So this model requires a lot of external input to get this thing bootstrapped versus the controller model. You know, you just pretty much execute the container.
Yeah, I mean, again, TBD what this is going to look like. We have 3 minutes left, and one other talking point was to kind of like see how the data model relates, and we kind of talked about this. I have a sequence diagram for creating a machine that I kind of want to show for webhooks. So just so that like we can actually reason about it like with some visual help. So in this example, like we have kubectl apply.
Sorry, is that linked in the document somewhere?
No, but I will add it just right
Okay,
afterward.
thanks.
Sorry, I'll refresh this. Machine. Okay, now it's bigger and better. We have a user, we do kubectl apply machine. There's going to be a new machine event that like gets fired off. Cluster API, like we run controller runtime, so it will kind of see that event and kick off the machine controller reconcile loop. This follows like what we have today, like in the machine. So we'll go get the cluster ref, and the API server will return the cluster that's related to the machine. We load the cluster extension configuration, which is kind of what we talked about before. We load the class ref, the infrastructure ref, which are both required fields. The infrastructure config here has like this star because it's not in v1 alpha 2 like native types. It's like something that's like external. So we'll kind of have to use like something like the dynamic client to kind of load this configuration. We have an optional part here. So like that takes in this flow, the bootstrap part. So the bootstrap is actually filled. We go call we load the provider ref in the bootstrap field. It returns a bootstrap config, and then we make a webhook request to the provider that's registered within the extension configuration. This will return some data in this webhook response. And we will hold that data in memory. So like, let's say that we want to generate like a kubeadm configuration. Would have like this bootstrap config would probably be called something like kubeadm machine config, something like that. We go call the kubeadm machine bootstrapper and say, I need a new like bootstrap configuration, and the kubeadm machine configuration can return something like, let's say, cloudinit or a bash script, something like that. We hold that stream of bytes in memory, excuse me, and then we do the webhook create call, and this is on the infrastructure provider. So let's say we're like kind of creating like AWS infrastructure machine, and the extension configuration, it's creating that machine. We'll go and like start doing that webhook create call and pass in the fields that will be defined as part of like kind of cluster API contract with the webhooks. If everything goes according to plan and the machine gets created, we got a response back with some data that, again, we expect as part of the contract. To cover some other use cases, we have like also post-boot request for the Bootstrap part. So this request kind of, it is optional because you need to have like a Bootstrap provider registered, but it covers use cases as in like, let's say that we have a bash script like returned here, but the infrastructure provider cannot use like that as a startup script or user data. This would cover like an SSH, excuse me, an SSH kind of provider that like could SSH into the machine and execute that script. And this is optional. So some provider might use it and find it useful or might not. At the end, we kind of just update the status of the machine and we'll get the new machine back and response. So in the webhook model, like kind of the most powerful thing is to dictate this flow. So how like this what happened, but that doesn't mean that providers can use their own controllers and their own reconcile loops to kind of have this loop outside of Cluster API.
I'm a little bit worried about, you mentioned SSHing into machines and doing things several times in result of those webhooks. I mean, is the intention that the webhook would initiate that operation and then return right away and it would just run in the background until somebody checks and makes sure it's done? Or is that meant to run synchronously?
It would have to be determined. It hasn't been designed yet.
Okay.
I know in this example it's synchronous.
We're already 2 minutes over, and
oh yes,
Cluster API.
We have the Cluster API.
Yep.
Okay.
All right. Thanks everyone.
Thanks, Talia, for taking notes. Just wanted to call that out. Thank you.
Yeah,
Thank
definitely.
you.